Hello, my name is Hudson Wagner. I'll be presenting on the environmental effects of geothermal wells and operations. So on the left, we have an already existing geothermal well uh, with the plant up on top of the surface and 5 miles below. Some of the permeated fractures, I guess, that are transferring heat. And on the right, we have the drilling equipment that would drill those wells. So there are environmental effects on both the construction side as well as the operation side. And we'll be digging into both those uh, pretty soon here. So just diving into the outline of the presentation, I'll be going over the overall importance of the growing geothermal energy sector, specifically the enhanced geothermal systems, and then the role of drilling in these enhanced geothermal systems, what that looks like, and then getting into the meat of the presentation will be mostly on the environmental effects of well drilling and some mitigation efforts that have been come up from the or produced by the sector. Uh, Most of the concerns are come from seismicity, ground subsidence, water quality, uh, emissions, and then finally some site operations and considerations. And just looking at this picture on the right, this is one of the first successful EGS drill uh, wells to be drilled. This was in 2018, and it reached some in China, and it reached some rock temperatures of about 185 degrees Celsius. So just the nature of geothermal being a renewable resource makes it essentially a carbon-free method for obtaining energy. So the environmental footprint is pretty small, but that does not mean that there are zero carbon emissions involved in the production of geothermal energy. But compared to some of these other carbon-based energy generation methods, uh, there's significantly less. So if we look at the Department of Energy graph on the left, you see that both compared to coal and natural gas, it's emitting much smaller, oftentimes 15 to 150 times smaller emissions than some of these non-renewable resources. One thing to note about the emissions and environmental impact of geothermal is most of the impact is coming from the siting and construction phases of the projects. And then once construction is finished, you'll see those emissions and overall impacts really dip down to, especially in the carbon emissions, to almost zero, depending on what kind of plant you're running. So one question I ask is, why do we care about these low carbon energy generation? And that comes from essentially the need to reduce annual CO2 emissions in order to hit some minimized warming over the next century, ideally somewhere below 2 or 1.5 degrees Celsius. And as a low carbon generation method, geothermal really has an opportunity to make an impact on reductions, uh, as energy is just one of the largest sources of greenhouse gases. So by 2050, ideally, we'll be reducing annual CO2 emissions by gigatons of carbon dioxide a year, and potentially even hitting a net negative emissions of carbon dioxide. So after noting that geothermal does have some large advantages over some of these non-renewable energy resources, especially on the global scale for emissions, um, I think it's important to realize and kind of dig into the fact that there are some uh, notable environmental effects on geothermal well drilling or on the environment from geothermal well drilling, especially for EGS, as you're digging hundreds of meters to tens of kilometers into the ground, um, and really using some of the same technology from the oil and gas industry. Uh, in geothermal, there are several different types of wells, including exploration wells, monitoring wells, production wells, and injection wells, um, most of which kind of operate similarly. And we can see a kind of diagram of what some of those wells can look like, from vertical to getting into horizontal, and how some of them operate. On the right, you have the bit at the bottom. This one is a polycrystalline diamond compact bit, and then um, just kind of operating with some drilling mud, pipe string, and using water or the mud to get out some of those cuttings and clean and lubricate the well, just to keep everything going smoothly. And realizing that these wells and geothermal plants have largely just localized environmental impacts, it'll be important for EGS sites to balance some of these nice geothermal resources with population centers and geographic factors. So this, starting at the top right, we have a map of uh, EGS sources. This is 10 kilometers deep, and I guess the darker red we're looking at, the better the geothermal resource. And just kind of matching that up with population centers. On the bottom right, we have population distribution by county. So largely concentrated, these geothermal resources largely concentrated in the west, in some of these less densely populated areas. So you can either balance out the transmission, or just making sure that maybe some of these projects are close enough to population centers to get there inexpensively, but not without being unsafe. Looking at the picture on the left, we have a picture of a geothermal site in Hawaii that ended up getting pretty dangerously close to a lava flow, and was getting some blowback in the community. And I'll go over this later. But there does have to be a balance for where these resources are, and also where the demand is for energy. So realizing that we are drilling wells that are kilometers deep into the Earth's crust, it's induced seismic events have become some of the most impactful environmental concerns for geothermal plants, and can potentially be disastrous for a project if any of these events get too large. Um, with the introduction and kind of growth and popularity of hydraulic fracturing and hydraulic shearing, this has especially become an issue. Uh, and looking at one of these projects in France, on the left, they've documented some of their events. So not an uncommon thing, especially with drilling more and more wells in one area. So there are a number of causes that can result in some seismic and induced seismic activity, dealing with geothermal wells as well as really any oil or gas well. Uh, but the largest three are the injection of cool water into hot geothermal reservoirs, the extraction of fluid from these reservoirs, or unbalanced extraction, I should say, and then high pressure injection of fluid used to enhance permeability. Um, the largest maximum observed event from a geothermal well was at 4.6 on the Richter scale. Um, Not something that people are seeing very often at all, but most common. And a lot of these projects you'll see from 2 to 2.5. Uh, and those are nothing ideal, but nothing too disastrous for a project. Another environmental concern that comes with some of these geothermal projects is ground subsidence, which often results just in the unbalanced withdrawal of fluid from the subsurface. Um, so really taking out more water than you're putting back in. Um, and this is common in rocks with low strength that are relying on water to provide some structural framework. That means like unconsolidated sediments, porous volcanic rocks, and rocks with high clay content. Um, Ideally, you can get into some rocks that are preventing subsidence, like granite and gneiss. Um, but this is a problem that's on the scale of either sinking on millimeters per year. So a small scale, but when dealing with some more residential areas, that may be adding up to be a real issue, especially on 25 to 30-year project timelines. Water plays a pretty large factor throughout the life of a geothermal plant, and concerns can stem from steps in well drilling to the disposal of the geothermal fluids, all the way to, and then as well as just balancing the fluid extraction with reinjection. There's a significant amount of water needed for well drilling as well as just plant operation. So, like I said, reinjecting all the fluid that is being extracted from these geothermal kind of areas in the ground, reservoirs, and just ensuring that after water is extracted, that it's properly handled, um, making sure nothing's too contaminated, and that it can go back into uh, the geothermal reservoirs. Some things that are used to prevent uh, kind of contamination during well drilling. Uh, it's pretty common to encounter areas that have high permeability near the surface, and that usually allows, not ideally, will allow drilling fluids to escape into the surrounding rock. So often, what industry will use are TZIMs, or thermally degradable zonal isolation materials, um, that are used to close off fractures that are not being stimulated and just induce some local fractures. So even though these are uh, chemicals, they are designed to break down into either water or carbon dioxide or other non-reactive molecules um, in geothermal reservoirs that are uh, at a certain temperature. So as long as they are at that degradable temperature, um, they will break down in a matter of either hours or days or weeks. And but if they are at lower temperatures, then that uh, could last for weeks or months. And of course, another thing to keep in mind is that the mud used for drilling often involves some chemical compounds that can react with chemicals in the natural environment. Um, Depending on the temperature, that'll change the viscosity and thermal properties of the mud, um, often for the worse. And some of these additives can also become unstable at high temperatures, uh, and that'll degrade the ability of the drilling fluids to do things like flow, lubricate, and seal. So, depending on the additives, just have to be pretty cognizant of temperature and the well their mud makeup, uh, chemical makeup of the mud uh, in the process of drilling. And once wells are drilled and geothermal plants are operating, much of the concerns are just, at least with water, are coming from the geothermal fluids that are being, first of all, extracted from reservoirs and then potentially re-injected into the reservoirs. So these geothermal fluids can range from dilute solutions to concentrated brines and are often handled on a case-by-case basis. Um, it's usually preferred that the uh, geothermal fluids are immediately re-injected um, for disposal, but there are some environmental concerns sometimes, and potentially um, a use for the brines or metals in the brines for resource extraction. On the left, there's a picture of a California plant that in 2016, I believe, was proposed could uh, mine lithium. So this is a pretty expensive process and in the very early stages of research, but um, looking at some of the brine concentrations on the right, we do see some pretty valuable resources that in the future could be mined or extracted from the geothermal fluids, and it's essentially turning a operational cost into um, something that can be sold and just another income stream for some of these producers. So when plants have to decide what to do with their geothermal fluids that have already passed through the plants or the geothermal facility, they have a few considerations they have to make, and that includes the makeup of the geothermal fluid. So if you do want to extract any of those minerals, if the geothermal fluid needs processed at all to meet environmental regulations, and then at times it is important to find disposal locations for the water once it has been cooled and can be allowed back into the water table. So in addition to water concerns, there are also some emissions concerns that can be contributed to geothermal. Um, the three gases that are of chief concern are carbon dioxide, hydrogen sulfide, and mercury. So getting into each one, carbon dioxide um, is has a pretty converse relationship with temperature. So the higher temperature that of the reservoir you're reaching into, the more carbon dioxide you'll have releasing. But it is important to remember that these carbon dioxide emission rates are 15 to 150 times less than other energy sources. And just looking at the graph on the left from Lafayette, you can see just how low that is, pretty comparable to nuclear energy. Hydrogen sulfide is naturally occurring in the environment at usually less than 1 part per billion, but is usually pretty present in some of these deeper wells or deeper reservoirs, and is often the cause of the rotten egg smell uh, that is attributed around a lot of the geothermal plants. Um, and then mercury sounds a lot scarier than it is in some of these plants. Um, Geothermal engineers have really figured out how to uh, get rid of that from the emissions, and it's so that it often is naturally occurring in a liquid state. It has a very low um, boiling point and will uh, occur in some of these wells just as a gas. Um, but it's pretty cheap to kind of filter out, and it's pretty common that the recovery of mercury in these systems are well beyond 90%. So finally, we're getting back into the site considerations for these geothermal plants. Looking at the graphic on the right, you see geothermal, the second from the bottom, the only energy generation source that has a lower land use intensity than geothermal is nuclear power. So pretty impressive on that scale. But even so, there should be some considerations for siting, including everything from animal migrations to nearby communities. Um, Pretty important to have discussions and just realizing that these are still pipelines and regulations have to be followed. And then just coming back to the community engagement, um, stressing that it is pretty important for the long-term success of projects. If I can just come back to the power plant in Hawaii on the left, it's been sued several times by some local populations for being an environmental hazard, for being, I guess, this close to a volcano. There are some dangers and some energy security problems with just that siting. And then on the right is the New Zealand's Wairakei power plant. It's been developed as a joint venture with the local Maori people. So just on the flip side, there's some co-benefits for the Maori people, and some of these communities in New Zealand do get some. Both are getting some energy security, and Maori people are getting some funding from that project.